Hello friends, I'm Jagdish Park Associate. Today's topic is engineering thermodynamics. So in engineering thermodynamics, I will be explaining a numerical problem. And this numerical problem is taken from the chapter Fundamental Concepts of Thermodynamics. Okay. So before going to this video, please press the subscribe button of our channel, the Mechanical Engineers team, and also click the bell icon so that you will get the notifications for new videos. So let's begin. First, I will read the question. A pump discharges a liquid into a drum at the rate of 0.032 meter cube per second. The drum, 1.50 meter in diameter and 4.20 meter in length, can hold 3000 kg of the liquid. Find the density of the liquid and the mass flow rate of the liquid handled by the pump. Okay, so this is the question. Now I will analyze the question. A pump discharges a liquid into a drum at the rate of 0.032 meter cube per second, which means for every 1 second, the volume of liquid coming out from the pump is 0.032 meter cube. The drum, 1.50 meter in diameter and 4.20 meter in length, can hold 3000 kg of the liquid, which means the diameter of the drum is 1.50 meter and the height or length of the drum is 4.20 meter, and the maximum amount of liquid the drum can hold is 3000 kg. So in this question, by using the data of volume flow rate, diameter, length and mass, we have to find the values of density of the liquid and mass flow rate of the liquid handled by the pump. Here, what do you mean by mass flow rate? Mass flow rate is nothing but we have to find for every 1 second how much kg of liquid is being discharged from the pump. And one more thing, the density of the liquid remains constant. That is, the density of liquid when it's flowing through the pump and the density of liquid inside the drum remains the same. To be more precise, the density value is the universal value. Now I will illustrate the given conditions. First, the volume flow rate is 0.032 meter cube per second, which is taken as V dot. The diameter of the drum is 1.50 meter, which is taken as D. The length of the drum is 4.20 meter, which is taken as L. And the mass of the liquid is 3000 kg, which is taken as M. By using these four data, we are going to find the values of density of the liquid and mass flow rate of the liquid handled by the pump. Now I will move to the solving technique. First, we will find the value of volume of the drum, which is taken as V. First of all, why we have to find the value of the volume of the drum? Why? Because for finding the value of density of the liquid, we have to find the value of volume of the drum. You people may ask, why can't we use the value of volume of pump for finding the value of density of liquid? Of course, we can use the value of volume of pump for finding the value of density of liquid. But in this question, they have not given the data of volume of pump, and also they have not given the data of mass of liquid flowing inside the pump. So when these two data are missing, it's highly impossible to find the value of density of liquid. The only data they have given for pump is the volume flow rate. Of course, we can find the value of density of liquid by using the value of volume flow rate. But for finding the density of liquid, we need another data, and the data is mass flow rate. Unfortunately, in this question, we have to calculate the value of mass flow rate. So in this case also, the mass flow rate is missing. Therefore, it's highly impossible to calculate the value of density of liquid. In simple words, according to this question, we can't calculate the value of density of liquid by using pump parameters. We can calculate the value of density of liquid by using drum parameters. So friends, now you have understood why we are calculating the value of volume of the drum. Okay. So now we'll get into the calculation. Generally, the shape of the drum is cylindrical. Therefore, we have to use the formula of volume of cylinder. And the formula is pi by 4 into square of the diameter of the cylinder into length of the cylinder. So similarly, the volume of drum will be pi by 4 into square of the diameter of the drum into length of the drum. Okay. So therefore, the formula will be V is equal to pi by 4 into D square into L. So in this formula, we know the value of diameter and length. So just substitute the values. We get V is equal to pi by 4 into 1.50 meter whole square into 4.20 meter. So here 1.50 meter whole square is 2.25 meter square. So the next step will be V is equal to pi by 4 into 2.25 meter square into 4.20 meter. Now in this RHS I'm going to split the numerical terms and S units. So the next step will be V is equal to pi by 4 into 2.25 into 4.20 into meter square into meter. So here 2.25 into 4.20 is 9.45 and meter square into meter is meter cube. So the next step will be V is equal to pi by 4 into 9.45 meter cube. Here pi by 4 into 9.45 is 7.42. So the next step will be V is equal to 7.42 meter cube, which means the volume of the drum is 7.42 meter cube. Now we have found out the value of volume of drum, and also we know the value of mass of liquid filled inside the cylinder. So by using these two values we can easily find the value of density of liquid, which is taken as rho. The basic formula for density is mass by volume. So similarly, the formula for density of liquid will be mass of the liquid divided by volume of the liquid. So in this formula we know the values of mass and volume, so just substitute the values. We get rho is equal to 3000 kg divided by 7.42 meter cube. So here 3000 kg divided by 7.42 meter cube is 404.203 kg per meter cube. So the next step will be rho is equal to 404.203 kg per meter cube, which means the density of the liquid is 404.203 kg per meter cube. Now we will find the value of mass flow rate of the liquid, which is taken as m dot. For finding the value of m dot, we will use the formula of density, and the formula is density is equal to mass flow rate divided by volume flow rate. In this formula we know the values of density and volume flow rate, so we can easily find the value of mass flow rate. Okay, so we'll write down the formula, and the formula is rho is equal to m dot by v dot. Therefore m dot will be equal to rho into v dot. So here we know the values of rho and v dot, so just substitute the values. We get m dot is equal to 404.203 kg per meter cube into 0.032 meter cube per second. So in this RHS I'm going to split the numerical terms and S units. So the next step will be m dot is equal to 0.032 into 404.203 into meter cube per second into kg per meter cube. So here 0.032 into 404.203 is 12.93 and meter cube per second into kg per meter cube is kg per second, because meter cube gets cancelled. So the next step will be m dot is equal to 12.93 kg per second, which means the mass flow rate of liquid handled by the pump is 12.93 kg per second. So friends, we have found out the values of density of the liquid and the mass flow rate of the liquid handled by the pump. Okay, I hope you all would have understood. If any doubts are there, please do comment in comment box, and remember to like, share and comment on our videos. And don't forget to subscribe our channel, the Mechanical Engineers team, and also don't forget to click the bell icon. Okay, thank you friends.